what we will be talking about is exactly what you can see in this picture here, is foundations. Now, in N4, you were taught about foundations. You already know what foundations are, what the purpose of foundations are. But the objectives then of this lesson is just to explain major requirements in the design of foundations. Okay, and talk about the main functions of foundations, which you already know, and we will differentiate between shallow and deep foundations to say what is the difference between those. We will talk about the difference as well in actually in identifying the situation when you should use a shallow foundation and when you should use a deep foundation. We'll talk about all these things. Like I said, this is just extra information, extra new information on top of information you already knew. Okay, so I don't need to define a foundation because you already know it, but basically it's just to satisfy and remind you it is just the structure that transmits the load of the building to the soil. So the structure that's at the bottom, that is what we call a foundation, and its job is to take the loads of the building. That means the weight of the building, the weight of the people that will be on the building, the weight of the furniture that's going to be in the building, everything that's going to be on the building. It takes that weight and distributes it to the ground. Okay, so that is the function of a foundation. Now, there are certain design considerations that need to be made to decide what type of foundation should be used. And the kinds of foundation depend on the ground condition. What type of ground is there? Is the soil sandy soil or rocky soil? For example, if the soil is sandy, then probably piles will be used. But if it's rocky, then probably shallow foundations. But we'll get to that. It's just to say the ground conditions really matter. And the person who does the ground condition is the geotechnical engineer, also known as the soil engineer. So also you need to consider the groundwater conditions, as in where is the water table in reference to the building, in reference to the foundation. Okay, so water table is very important. That's what we mean when we talk about groundwater conditions. Also, is the site a wet site or a dry site? Okay, so that all matters. The site conditions, the environment surrounding the building, surrounding the site as well. Is it a busy place in terms of there's other buildings around, or it's just a bush, or is it, a mountain? Is it a valley? What type of environment is it? Okay, and then we'll talk about the structure of the building as well. So you need to consider all of this. And by the structure of the building, it means, is the building a high-rise building, or is it just a one-story house that you are building? So all of these are just design considerations, things that you need to know before you design the foundation. Okay, now some of the requirements, as well as it says here, structural requirements is that the foundation should be such that it's safe and it's able to carry all the load of the building combined. Okay, and then the constructional requirements, Now those are schedules. Schedules is like how much time do we have to build the foundation? When can we start it and when can we end it? What resources do we have? How much money will it cost to build the budget of the foundation? All of these are just some requirements uh, of the foundation. And then there are specialities. Is it expensive or difficult to repair? And all of these things is like, is it constructed underground? Just what's happening on site. You might need specialists to come and deal with the site conditions. Like, for example, I've already spoken about the geotechnical engineer, that his specialty is needed, especially if the site conditions are severe. And by severe, I mean wet or very rocky or whatever the case may be, but severe. Okay, now let's talk about the types of foundations that can be built. Basically, there's two types, okay, and under each type there are subtypes under it. As you can see here from the picture, shallow foundations. Shallow means they are small in size, like really short, and then there's deep foundations, meaning they are really long. Okay, it's foundations. That's how we separate them. Now, under the short, shallow foundations, the types of foundations will be isolated footings, will be wall footings, will be combined footings, will be cantilever footings. We'll talk about each one of them, just get a deeper understanding of each. Don't worry about it. And then under deep foundations, we have pile foundations, which are very long. And then we have pier foundations, which are also long, but there's a slight difference between the two. We'll talk about it as well, just to get more detail on it. Don't worry about it. Now, let's talk about the shallow foundations. Now, these are usually located no more than 3 bricks below the lowest finished floor. Remember, in constructing a building, we normally use a brick, normally use bricks here in South Africa to construct buildings, and the bricks that you were drawing last in N4 and in N3 as well, which are 110 in width. Okay, so if you can imagine that, that's how shallow they are. 3 of those bricks. Okay, a shallow foundation system generally used when the soil close to the ground surface has sufficient bearing capacity. What does that mean? What's bearing capacity? Bearing capacity is basically the soil's ability to carry the building. Remember, foundation is taking the load from the building and it's taking it to the ground, it's taking it to the soil. So the soil needs to be able to carry the building. Okay, so if there's sufficient bearing capacity, if the soil can handle the building, then you do a shallow foundation. Okay, that's the part you need to understand. Underlying weaker strata do not result in undue settlement. So all that's saying really is that if the soil is weaker, then there will be settlement. Settlement means that the building will start sinking. Settlement is the building sinking. So if the building sinks, then that's what we call settlement. Okay, so now those are shallow foundation criteria when you build shallow foundation. Let's talk about footings. Footings are structural elements which transfer loads to the soil. Now, A footing is just another word for the actual foundation. Okay, so a footing is a foundation, but a type of foundation. Okay, so it's basically, you can literally remove footing there and put foundation as well, but it's a type of foundation you'll see. Now let's talk about the types of footings. As you can see here, we have the footing, which is the foundation, and a column. Now these ones are called the isolated spread footings. Okay, the first one that we need to, the first type of shallow foundation that we need to understand is this one called isolated footing. The reason it's called isolated is because each column has its own footing, has its own foundation. So remember, building has columns in corners and sometimes in the middle of the building, just to carry the weight of the building as well. So it takes the weight of the building and it transfers it to the footing or the foundation, and the foundation transfers it to the soil. So isolated, what they're talking about being isolated, it means this foundation is carrying one of the columns. Okay, and then this one is called a wall footing because the entire wall of the building is on top of this foundation. Okay, and it's continuous. As you can see, the entire wall, it's no longer isolated, it's not a column, but it's actually the entire wall, and the entire wall is on the footing or the foundation. And then as we continue, this one is called a combined footing. What is being combined? As you can see here, the columns are the ones that are being combined. There's two columns that are being combined in one footing. Okay, so this is a combined footing. Okay, and then we have a cantilever strap footing. Cantilever meaning, okay, you see it's isolated. This is a column, that's a column, but then also in the middle here, the footing is continuing. You have a middle footing. So this is called cantilever or strap footing. So it's like a strap. There's a strap footing in between isolated footings. Okay, so there's a strap between, so this one is called strap footing. And then as we continue, this one is called a raft footing or a mat footing. As you can see, it looks like a mat. If you can just imagine a mat for wiping your feet. As you can see over there, we've got the mat, and then we've got different types then of a different number and put a different number of columns put in, as you can see here, they're put in a particular order. Okay, so it's called a raft or a mat footing. Okay. Okay, now that's all we needed to understand about the shallow foundation. So all of these are shallow foundations. As you can see, they've got columns, and the foundations themselves, which we call footings, are actually very, very short. Now let's talk about deep foundations. This is where now we're going to speak about the piles and all of that stuff. Now it says this, yeah, the shallow foundations may not be economical or even possible when the soil bearing capacity near the surface is too low. Okay, remember when we spoke about soil bearing capacity, we're speaking about the soil's ability to carry the building. So now if that soil's capacity to carry the building is very low, that means that soil cannot carry the building, then something can be done. We can introduce piles to make sure that that soil can eventually be able to carry the building. To bring more stability, we bring in the piles or the deep foundations. Now shallow foundations won't work. So if we look here, this is an example of a pile. As you can see, the pile is actually very long. The idea is that how long should the pile be? The idea is that you should put a pile. It goes through the sandy soil, whether it's sandy soil which is weak, or watery soil, or water. In fact, you then put a pile that is as long as until it reaches a hard rock on that particular site, because remember the sandy soil will be the top soil, and then as you go deeper it becomes harder and harder, and when you reach a and when you reach a hard rock, bedrock, then that's how deep your pile will be. Okay, there you go. That's another example over there. This one has a hard rock, but in the event that there is no hard rock, then you just have to make your pile even deeper, okay, until it's so deep that it can carry the building. Now, there are calculations that can be done to determine how deep exactly the pile has to be, or how deep the deep foundation has to be. Normally, it's the geotechnical engineer who designs this. He considers the types of soil, and also using that type of soil, he can then calculate how long the pile has to be. Okay, there we go again. This is just to explain that the types of forces experienced by the pile, that there's a momentum, there's forces all around it, keeping it stable. Okay, as you can see, let's look at here. You have a column, and then you have we call it pile caps. Okay, but also it can be just a shallow foundation, and then under that shallow foundation you then put the piles to make sure that the shallow foundation stays intact. And then what happens is that this load, the weight of the building and all its components, comes on the column distributes it to the file caps, and then the file caps transfers it to the piles, and then the piles transfer it to the soil itself. Okay, this is just a different conversion of the piles, that you can also put them on in an angle. They don't always have to be straight down. Okay, pile cap, that's another picture of it over there. Now, this is a pier. Normally, a pier is used in, like, if you've ever gone to the beach, you would see that actually there are walkways on the beach that are going into the sea. As you walk on the sea, on those platforms, under those platforms, normally they use piers. So they look like piles, but they are much bigger than piles. That's why even here, as you can see, it's much thicker. This is a column, and that's a pier, and it goes all the way down. It's also very deep as well. It's just that it's stronger than a pile, bigger than a pile, thicker than a pile. That's what we call a pier. That's the difference between a pier and a pile. A pile is smaller in terms of thickness, and a pier is bigger. Okay, I think we're going to stop it there for this understanding, but I hope you are really understood what we are talking about there. Okay, why reinforce foundations? Well, this part is just talking about the actual reinforcing of the foundation, but I just wanted us to speak about the types of foundations. I wanted us to understand the types of foundation today, The purpose of this lecture is just to understand those. Once you understand those, then we can come now and talk about the actual reinforcing of the types of foundations, as in how do you reinforce them, because all of these things need reinforcement in order to be stable. They need reinforcement in order to actually stand. Okay, so what I'm going to do now, I'm going to stop sharing that. Well, welcome back. You can see the full picture of myself. But like I said, I hope you understood everything that we spoke about today. But in the event that you didn't understand, you can always contact me through